Bene, buongiorno a tutti e sono davvero ben lieta di darvi il
Good
benvenuto.
morning, ladies and gentlemen. I'm very happy to welcome you here at this new Ocrim's webinar. There will be two appointments today, one now at 10 a.m. and another one at 4 p.m. For all our colleagues from all around the world to have the chance to join us and attend the webinar. Some of you maybe already know me because these online sessions have involved my presence since the very beginning. And I also met other people live in September in Cremona. My name is Anna Buffa, and I deal with communication in the food sector. And I've been doing it for about 15 years now. I will be questions, you can send them at conferenceroom.ocrim.com. Considering the social and political context of this period, we decided to deal with a specific topic today, together with Paolo Molinari, who is in charge of the technical and electrical and automation department of Ocrim. He deals with the team of developers and monitors the processes through the improvement of processes and procedures in production. So, together with Paolo, we are going to talk about the optimization of energy within the milling plant. He prepared a presentation including 4 parts. So now I leave the floor, Paolo, for taking the floor and giving the presentation. Thank you, Anna. Thank you very much for your introduction. So, our aim today is to, let's say, raise your curiosity. And we would like to start with this question: how to optimize energy consumption in the milling plant without hindering the performance. Our technological department, the research and development for the electrical and automation department, identified four main points and a series of proposals that are aimed at the optimization of consumption, which is something very important at the moment, considering the critical context related to energy supply. So these are some quite simple ideas that we should not take it for granted, because we should avoid wasting energy or using energy in a bad way. And so the first point is the quality of the electrical network. The second point is to use some auto-regulation or self-regulation for the nominal performance of the machine. The third point, which is maybe more innovative, that is the application of smart automation functionalities for our processes, for them to be more, performing and effective. And last but not least, the concept of modular mill. So, a very quick overview about the activities involved in the electrical network in order to ensure quality for the milling plant. And the first thing is maintenance. Maintenance should be performed by qualified staff and trained staff in order to check up all the clampings and electrical connections periodically, regularly, in order to avoid any possible fire. Then keep filters and electrical environments clean, together with the filters and the ventilation system, in order to ensure a good ventilation and cooling of electrical panels, in order to avoid too high temperatures and short circuits, and also avoid any kinds of problems due to possible, detergents or other materials that might light up fires. Then the second point is a very important one, which sometimes is taken for granted, um, and it is related to an appropriate power factor improvement system. So the PFC um, should be sized appropriately with an automatic control and with a 95% saving. Thanks to this, we can avoid to have some penalties, some fines in the energy billing, and also it allows to capitalize on the work carried out by the machines. A technological device that is already used on our machines, because what we describe today, what we talk about today, is something that we have already launched on the various plants made by Ocrim, is to harness the behavior of the machines for their overall capacity and not nominal capacity. So if we think of a pneumatic and aspiration system with a fan, we can modulate its rotation regime. If we include a vacuum sensor and we add it in this pneumatic and aspiration system, we can send an analog signal to the central automation system that will create a loop with the inverter. And so there will be a threshold in this pneumatic and aspiration system that is read by the sensor that can regulate the inverter behavior and its rotation on the basis of the needs of the plant, and not just, harnessing using the fan and its nominal data. So there will be an important saving just by reducing the rotation regime of the fan by some hertz. And there will be an important impact in terms of energy saving using the machine for the actual needs of the ongoing cycle. Then there is another important point, which is not closely related to the production, but is quite important in terms of energy consumption in the plant. And it is the automation and in particular, the lighting system. The lighting systems that we used are domotic and smart. They are, all machines are equipped with this kind of systems. They are not optional. So there is an LED LED technology for the lighting lamps, and we always guarantee, thanks to this, some energy saving. Ocrim also suggests a cockpit. A control panel that can really drive the different lines within the plant. So managing the switching on and off of the various parts in order to avoid that they are used that they are not used properly. And so there is the lighting system, both internal and external, that are managed this way. And then another easy thing is to have sensors in area where there are lots of people, so that the lights will be on only for the time needed by the person to work there. And this is true for, stairs, corridors, restrooms. So minimize the lighting of the lamps and reduce it only to the necessary time. Another thing that is quite smart, clever, in my opinion, is to divide the various floors. So the lighting of the various floors, creating some sub areas, sub zones that are mm, driven by the automation system. The first area, the first zone, ensures a lightning flow that allow to perform regular activities such as the machine inspection, walking on the floor, controlling some sensors or checking up the levels within the machine. So this kind of light flow is enough for the people to perform their everyday work without having too much impact on energy consumption. And then a second area, so a second tab with some touch buttons on the floors, it can be possible to switch on all the lighting system with a higher lighting flow in case of extraordinary operations such as the maintenance of the machines. So the light will be based on the kind of activities that we are performing, and this will allow us to save consistently um, in terms of energy. Then another point for the smart automation, there is a PLC system and also an MES, so a management system collecting all the production data and allowing for the management of the various jobs or working cycles on the basis of the work plan in our production process. In order to optimize consumptions at best, we need to know how much we consume. So making this kind of investigation is fundamental. Otherwise, it is difficult to understand what kind of measures to take in order to save energy. Our proposals is to have on all panels a multi-function smart system collecting the consumption data and sending them to our central automation system. The central automation system can produce some reports that can be filtered according to the criteria that we prefer. It can be weekly, monthly, and so on. And thanks to these reports, we can find these statistics on the consumption data when in production. So if we want to give an example, so energy consumption considered on the basis of the various cycles in an averaged plant of 400 tons per hour, we can see that our smart system uh, keeps into account the energy rate costs. So here we have just considered two ranges, daytime and nighttime, but we can also have several ranges dependent on the energy supplier and on the fares. So there is this time grid divided by tasks or jobs. So on the right, we can see all the work cycles that we set in the machine all along the working day. Every cycle, every task includes the amount, so the tons processed and the hours needed. All the system is customizable, so you can set priorities for one cycle or another, and then the system, on the basis of an internal evaluation, will position in the time grid the different tasks rationally. So the best planning within the 24 or 48 hours will be set, and there will be suggestions on where to put the cycles, when to start the cycles, on in which parts of the day or of night, on the basis of the energy consumption. For example, cleaning and milling are generally customized as the main cycles, so the system will tend to put these two parts during the daytime, whereas other um, cycles, other tasks such as screenings or recycling will be performed at night in order to benefit from more, profitable and a lower cost of energy. We might also move the daytime performances, the daytime tasks, to night if we think that the plan is better or if we have specific needs. So everything can be edited or customized according to the specific needs. This can be a very smart tool to help us and have, like a snapshot of the production planning without hindering the production process, but giving benefits in terms of energy saving. Within the same application, and always considering the two cost ranges for energy that we considered before, we see that there is 35% uh, advantage if we harness, let's say, the two ranges, and if we, on the contrary, performed all the work cycles in the most expensive range. Another thing that is possible is to set a maximum threshold or a threshold where we receive an alarm. And when we exceed that threshold, our system will suggest what kinds of non-priority cycles we might move to another moment of the day. So, for example, if we don't want to go beyond a specific threshold, um, we have this support that classifies some processes as um, not priorities. And so we can like put this cycles, these tasks in standby and perform them only at other moments set by the plan. I think that we can conclude these ideas by introducing the concept of modular mill. That is a kind of mill for a whole milling cycle divided into two sub-lines. So thanks to the automation of the system, the milling line can be um, driven symmetrically and divided so that parts of the line are remain in standby, and maybe there can be ordinary and extraordinary maintenance procedures performed. Um, and the second sub line will be the only one switched on and working. This will not hinder production or reduce production, and at the same time will allow for performing the maintenance, and this will ensure and guarantee some energy saving, but in particular continuity in the production, together with the possible maintenance moments. Um, and then the second sub line um, can be switched off in order to do the same on the second part of the line. This said, these are all the proposals that I had to give you, and I hope that I answered some of your answers or answered some of your questions, and that I satisfied your curiosity. Thank you very much, Paolo. I think that the proposals that you suggest are always very interesting. There are questions, so we have received some. And I would like to ask you, how much saving can we have compared to in touch automation? Well, the relative saving per cycle is around 30% because this allows us to put the production cycles that do not need continuity in the energy cost ranges that cost less. And so the final impact per production cycle is around 30%. So almost one third. Well, I think that this is very high and significant. And apart from what we are experiencing now in terms of, energy costs that are rocketing, this can be a very useful tip also for the future. Also for sustainable reasons, to be more environmental friendly. Yes, exactly. And let me add that apart from the night and day um, approach, we can also you know uh, move some part of production at the weekend where generally the costs of energy are more favorable. So this is another thing included in the smart automation. Well, for such a plant, working at the weekend is already something very profitable and that can be used easily compared to maybe other companies. If there is no automated system, what about the electromechanics? Well, we cannot benefit from these functionalities with electromechanical plants because these kind of plants require, the preparation and skills of an operator that needs to set it up in the best way. And so there are logics and algorithms that facilitate the production of the plant. And this would also, require operators with less skills. So it is actually a disadvantage in this sense. So you have already answered to the second part of my question about the management of resources. Instead, in terms of automation, what does it mean? Well, for resources and optimization, automation allows for a series of tools and functionalities that are smart and that can really solve some kinds of conflicts. And the operator can benefit from these tools that allow them to have some operational activities that are more flexible, lean, and they can pay attention to other aspects because they do not need to always say 24/7, let's say, in front of a monitor, in front of a screen to check the production, because most of the problems, most of the warnings are solved automatically. Great. So, Mauro, I think this is all. If there are other questions that you haven't asked, you can write conference room at ocrim.com. So I think that this is all for this morning, and we can meet up here in the afternoon at 4 p.m. Thank you. Thank you, everyone. Thank you. Have a nice day.